Hello. We will now be doing questions 11 through 16 in algebra and functions. So let's go straight ahead to question 11. Amy is 2 years older than Bill. The square of Amy's age in years is 36 greater than the square of Bill's age in years. What is the sum of Amy's age and Bill's age in years? So we are giving a mathematical expression in words. So let's convert these words to a mathematical expression. So we're gonna let A be the number of years that that Amy has, and B is going to be the number of years that Bill has. So A is 2 years older than B. This makes sense. A is 2 years older than B, or Amy has 2 more years than Bill. Now, the square of Amy's age in years is 36 greater than the square of Bill's age in years. So now, what is the sum? So all we have to do now is we're just going to have to solve this system of equations. So easily I can see that A equals to 2 plus B. Let's put this 2 plus B into A, right? Because we can substitute A into this equation. So this is basically going to be equivalent to 2 plus B squared is equal to 36 plus B squared. Let's solve this out. 2 plus B times 2 plus B, because that's what this really means. 2 times 2, 4. 2 times B, 2B. B times 2, 2B. B times B, B squared, which is really just B squared plus 4B plus 4. It's going to be equal to 36 plus B squared. So now let's cancel out our B squares. Get our B on one side of the equation. We have a 4 here, minus 4. For B, B is going to equal to 8. So we know that B is equal to 8. So let's put B back into our first equation here. A is going to equal to 2 plus 8, which A is going to equal to 10. So A is equal to 10. They asked for the sum of Amy's age and Bill's age in years. 10 plus 8 is 18. So our answer for question number 11 is going to be 18. Let's take all this away. Goodbye. Question 12. The function f is graphed in its entirety above. If the function g is defined so that g of x is equal to f of negative x, then for what value of x does g attain its maximum value? So g, let's have it here. It's right here. G of x is equal to f negative x. So let's just make a table. See how g of x. I am very good at drawing straight lines. X, this is g of x. What values of x do we have here? We have from negative 3 all the way to 3. It's negative 3, negative 2, negative 1, 0, 1, 2, 3. Extend our line a bit more down here. Bam, 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 bam. Alright, let's do this. So when x is negative 3, so g, oh no, sorry, g of negative 3 is going to equal to f. Remember, when we do functions, we basically take the x and just replace the value of x into whatever x is in here. So that's going to be g of negative 3 is equal to f of negative, and x equals to negative 3, negative 3. So this really just means f is f of 3. Let's go here. What is f of 3 equal to? F of 3 is equal to 1. So with negative 2, when we put negative 2 back in here, that really just means f of 2. F of 2 is 2. F of negative 1, so f of positive 1, 1. F of negative 0 is just 0. That is 0. 1 is going to be replaced here, f of negative 1, that is just f of negative 1, negative 1, 2, f of negative 2, negative 3, f of negative 3, negative 1. So what value of x does g attain its maximum value? Which is the greatest number here? 2 is the greatest number here, so g attains its maximum value at negative 2. So our answer for question 12 is negative 2, or B. Let's move to question 13. So if x plus 1 squared is equal to 4 and x minus 1 squared is equal to 16, what is the value of x? So already that I can see from here is that on the right side of both of these equations, you have a perfect square. And then you've got a squared expression on the left side. So easily I can see from here is that we could probably square root both sides of both the equations, and then we could get rid of the exponent, because exponents are not fun to deal with. So x plus 1 squared is equal to, oh, my bad, equal to 4. So let's square root this side, square root this side. So we get rid of the exponent, so that's going to be x plus 1. Now remember, we're going to be square rooting this. So what we're going to be left with is going to be plus or minus 2. Because when you square, let's say we want to revert this value back into 4, we would have to square it, right? Well, when you square a positive value, let's say we square positive 2, we're still going to get positive 4. When you square negative 2, you will still get positive 4, right? So whether you square a positive or a negative number, you're always going to end up with a positive. So the square root of negative 2 is equal to the square of positive 2, which is 4. So we have to make sure that this is going to be plus or minus 2 and just not positive 2. Right? So x plus 1 equals to plus or minus 2. So x is going to be equal to plus or minus 2 minus 1. Subtract 1 from both sides. So when 2 is positive, it's going to be x equals 2 minus 1, or x equals to 1. The other scenario is x equals to negative 2 minus 1. X is going to equal to negative 3. Then let's do this equation. Oh, I'm sorry. X minus 1 squared is equal to 16. Let's square root both sides of the equation. X minus 1 square root of 16 is 4, but remember it's plus or minus 4. So then we're going to do x is equal to plus or minus 4 plus 1. We added 1 to both sides of the equation. So x is going to equal to 4 plus 1, or x is equal to negative 4 plus 1. So x could equal to 5, or x could equal to negative, oh no, x is equal to negative 3. So what value of x satisfies both equations? It's going to be x equal to negative 3, x equals to negative 3. So our answer is going to be A, negative 3. So 13 is negative 3. A. We're halfway there. Question 14. On the number line above, the tick marks correspond to consecutive integers. What is the value of x? So we know that because they are consecutive integers, first of all, both of these numbers have to be whole, and they're going to have a difference of 1, right? Because consecutive numbers, they're right next to each other. 1 and 2 are consecutive numbers. They are right next to each other on the number line. So we could easily rewrite this. So on a number line, if you're on the right side, it means you're greater than whatever is on the left side, right? So we could write that this number, x over 8, is equal to, remember they have to have a difference of 1 because they're consecutive, is equal to 1 greater than x over 12, or 1 plus x over 12. Now we just solve this like it's a normal algebraic expression. Let's get rid of the fractions. We don't like fractions here. Let's get rid of it. So we just have to multiply by the least common multiple, so we could get rid of the fractions and have a whole number. So least common multiple, 8, 16, 24, because 24 divided by 8 is 3. So what will happen is going to have 3x here, because 24 divided by 8 is 3x is equal to 24 times 1 is 24. 24 divided by 12 is 2x. Subtract 2x from both sides. We'll get x is equal to 24. And what is the value of x? Well, we just got it right here. X equals 24. Let's go with 15. The value of y increased by 12 is directly proportional to the value of x decreased by 6. If y equals 2 when x equals 8, what is the value of x when y equals to 16? So this is a proportionality question. And when something is directly proportional to something else, it follows the form of a is, this is the symbol for proportional, is proportional but is directly proportional. So you are going to have a constant factor. So you would say a is directly proportional to b. When you're directly proportional, you will have some constant factor that creates this proportionality. For example, let's say k was equal to 3. So a is going to be proportional to 3b. So for example, when b is equal to 1, a has to be equal to 3. Oh, I'm sorry. It has to be equal to 3. Because 3 is equal to 3 times 1. When b is equal to 2, a has to be 3 times that of b. So a is going to be equal to 6. So now we've got that out of the way. That means, let's rewrite this word expression into a mathematical expression. So the value of y increased by 12 is directly proportional to, we need our constant. We do not know what our constant is. The value of x decreased by 6. So we can't solve this without knowing what our constant is, but they give one example of a proportion. When y equals 2, x equals 8. Or when x equals 8, y is equal to 2. So let's plug this into here and let's solve for k. So when y equals to 2, so 2 plus 12, proportional to, or because we already have our k, we can just now simply say equal to k times x equals to 8 minus 6. So 14 is equal to 2k, because 8 minus 6 equals to 2. K is going to be equal to 7. So let's get this out here again. Oh yes, I love paint. Very useful tool. No, I'm just going to cover this up because I can. And I'm going to say bye-bye to you. You're taking up too much space. Alright, so and we know that k is now equal to 7. So what is the value of x when y equals to 16? We're going to plug 16 here. Just solve for x now. 16 plus 12. We have our constant now, so we're just going to replace it with equal. 7 times x minus 6. Or 16 plus 12 is 28 is equal to 7 times x minus 6. Divide. I'm very sorry. I believe that something went wrong with the mic. So I'm going to start from where I left off in question 15. I apologize. So 28 is equal to 7 times x minus 6. It's divided by 7. So 4 is equal to x minus 6. Add 6 to both sides. X is going to be equal to 10. So then our answer is going to be 10. So 15 is going to be B. 15 B. And our answer is 10. I just did this completely different than how I did 12 and 13. But that's okay. It's all good. It's all good. Okay, question 7, 16. Last one. Two cars are racing at a constant speed around a circular racetrack. Car A requires 15 seconds to travel once around the racetrack, and car B requires 25 seconds to travel once across the racetrack. if car A passes car B, how many seconds will elapse before car A once again passes car B? So let's draw a picture. So this is going to be our circular track. We got car A here. We got car B. Oh, I'm sorry. So if car A passes car B, so at some point in time, they're going to be at the same point. Where A is just passing B. Very realistic looking cars. I know, I'm an artist. So, and then what's going to happen is A is going to continue on, B is going to continue on, but A is faster than B. So eventually A is going to lap B again. So we know that this is a rate problem. We are given time, we're given a certain amount of distance. The amount of distance that is given to us is they travel once across the racetrack. So we do not know this distance, but we could arbitrarily call this racetrack length or the circumference of the racetrack. Let's arbitrarily call it D. We're going to, yes, D. So rate is equal to distance over time. So let's do R of A. So our distance is D. I know, very creative. We're just label it D because, yeah. So then the amount of time is 15 seconds. Meanwhile, RB is equal to, what is it? Runs around the racetrack. We arbitrarily called it D. And then 25 seconds. Now, basically, we are asked how many seconds will elapse before car A once again passes car B. So our variable will be T, or the time it takes for car A to pass car B. So we know that we are given time. And we know that when we multiply a rate by a unit of time, or how long an object, a car, or a person is going at that rate for, you're going to get the amount of distance that that object, person, car travels. For example, we're going to have the rate d over t times t. So this is the amount of time that you're going at this rate. We cross this out. We'll get left with d, or a measurement or a unit of length of how far you've traveled. So basically, well, we also know that if car A is to pass car B again, car A has to travel, another racetrack length ahead of car B. So in order for A to pass car B, A has to pass or go for an extra length of D, or an extra racetrack length. You could kind of analogize this to like a kind of a runner situation. Let's say you had a fast runner and a slower runner. If this fast runner wants to lap the slower runner, the fast runner knows that they have to basically run an extra race length ahead of the other guy in order to lap him. So we're going to use the same logic. So we know that the distance that car A travels has to be one racetrack length greater than the distance B travels. And as we said before, rate times a certain amount of time, you'll get the distance that you travel for during that amount of time. So RAD over 15 seconds times how long it'll take for car A to once again pass car B is equal to D plus the rate of B, which is D over 25 seconds times T. So now once you're here, all you have to do is solve it algebraically. Let's get the least common multiple of 15 and 25. It's 75, because 75 divided by 15 is 5. 5dt. 75 times d, 75d. 75 divided by 25 is 3. 3d t. Oh, I'm sorry. This was from when my mic stopped working. I'm sorry. So 5 dt. Oh, let's all divide this by t. 5t. Let's get rid of it. 75 plus 3t. Let's get t on one side of the equation. 2t is equal to 75. And then 75 divided by 2. T is going to equal to 37.5. So for 16, our answer will be 37.5. Thank you for listening, and I'll see you in the next video. Alright, bye.